Let's look at each of our examples here from 4.3. So we begin with y equals 2x to the third plus 3x squared minus 12x. And so we've got this nice cubic shape, right? And we realized that it's increasing from negative infinity to negative 2. And yep, there's negative 2. It was then decreasing from negative 2 to 1. And then it was increasing after that. And yep, that's exactly what we see. We then later found the local max and min. So I just highlighted them, but you can also type them in. So we found there was a local max at negative 220. And yep, we can see that right up there. And there was a local min at 1, negative 7. And yep, we see that right down there. Looking good. Confirming your answer. Always encourage it. Okay, the next example we did was x times parentheses x minus 4 to the third. And this is a funky one. So it comes down very sharply, has this very sharp turn, comes in, levels off just for a moment, and then keeps going. So we found we weren't looking for intervals of increasing and decreasing. This time we were just looking for local maxes and mins. But we can match it up with our chart, right? So it's decreasing from negative infinity to 1 right there. Then it increases from 1 to 4. All right, there's 4. And then it increases again. So it's not increasing at 4 itself. It pauses there, has a horizontal asymptote, but then it picks it up again. We found that there was a local min at 1, negative 27, way down there. And yes, that is true. And there's no local max. No local max. Okay, then we went on to concavity. And we looked at x to the fourth e to the negative x. What is this going to look like? Okay, interesting. So it kind of comes down, levels off there at 0, gets rather flat there, and then has this kind of bump, and then looks like a horizontal asymptote towards 0. All right, this time you're looking for concavity. So let's investigate this. So eventually at the end we found these inflection points at 2, and then the y-coordinate was 16e to the negative 2, so that's a point on the graph. Okay. And we found another inflection point at 6, 1296. Wow, e to the negative 6. And there's a point on the graph. Okay, so we found that this graph, and the origin is important. So this graph is concave up, and it's kind of hard to wrap your head around for a second, but it's curving up all the way until it gets to 0. Then at 0, it flattens out. So right at 0, there's a horizontal asymptote, which is not hard to see. But because of just the nature of the way it flattens out, even the second derivative equals 0 there. Okay, so it flattens out, then it goes curving up again, and from 0 to 2, it's concave up again, still curving upwards. But then at 2, it hits that inflection point, and at that moment starts to bend back the other direction as concave down. It's concave down until it gets to 6, and then at that moment starts to bend back up, and it almost looks like a straight line there for a while, but it's barely bending back and curving upwards. Now this is interesting. It's easy to associate concave up with like going down and coming back up, but that's not the case here. It is curving upwards, but it never makes it never turns and starts going up. It's just curving away from the x-axis. So it is still curving up, but so gradually that it actually continues to approach the x-axis as it gets further out. But yeah, the point being, these are the inflection points where it's, it flips over. And that's what we've got. Okay, we had one last question with the second derivative test. It was r of x equals 1 plus 6x squared minus 4x to the third. Okay, got this cubic kind of thing going that way. And with the second derivative test, we realized that we had a local max at 1, 3 and a local min at 0, 1. And yep, that's definitely the case. And we can tell, yep, here it is concave up, and here it's concave down. And so we get those local min and local max. There you go. Now, in these cases, that last case where it flattened out at 0 and the second derivative actually equaled 0, that's kind of a bizarre situation. Here it's much more typical where, yep, it's concave up all the way through, and it is concave up at that minimum, and this is concave down all the way through. It is concave down at that maximum. Every single point is concave down there. Okay, that's all of our examples.